Alright, so today we are talking about length, measuring length, right? In deciding which instrument to use in measuring length, it's often important to consider the nature of the object whose length we are to take. So for objects like a pen, we might want to use, for example, a 30 centimeter ruler. So this is a 30 centimeter ruler. And then if we want to find the diameter of a steel object, for example, the vernier caliper and the micrometer screw gauge are obvious candidates. So this is the vernier scale, the vernier caliper. And we'll talk about this in detail later along the video. So in summary, for very large distances, you might want to use the odometer or the measuring tape or the click wheel. This is the odometer, usually found in cars, the speed meter, right? And then this is the trundle wheel. The trundle wheel, there are many names for this instrument. Trundle wheel or the click wheel. Sometimes they say it's the surveyor's wheel, right? Surveyor's wheel. So these are the instruments that we use for measuring long distances. And for medium lengths, like you have just seen with measuring a pen, you might use a 30 centimeter ruler or the meter ruler, which is 1 meter in length. And then there are very small lengths that will require us to use the micrometer screw gauge or the vernier caliper. Right. And I want to believe that you are familiar with the ruler. So the idea behind using a ruler is deceptively simple. You just place the object against the ruler and then obtain the reading by subtracting the readings at each end of the object. But that's not necessary most of the time, because the object is placed at the 0 mark. As you can see in our case here, the object is placed at the 0 mark. So all you have to do is take the reading at the other end of the object, and that's about 8.5. Yeah, 8.5 centimeters. And I must mention that the accuracy of the ruler is 0.1 centimeters. That's really important because let's look at this diagram closely. Please don't be tempted to, I think in this case it perfectly aligns, but there are some cases where you won't be really sure the division at which the end of the object is. For example, if we were not sure whether the end of this pen was at 8.4 or 8.5, maybe we might have assumed that it's at 8.45. But that's really wrong, because the accuracy of the ruler is 0.1 centimeters. So you can't add an extra decimal place. We can say 8.45. That's totally wrong. We must first consider the accuracy of the instrument, right? So if you aren't sure, just take the reading that's close, the division that's close to the end of the object, right? Alright, so now I want us to talk about the vernier caliper. That is the vernier caliper. Well, there's usually some extension, and we call this the depth probe. The depth probe, right? So a vernier caliper is just an instrument that measures the internal or external dimensions and distances of an object. It usually allows us to make more precise measurements than we could otherwise do with regular rulers and the likes. And the accuracy of this thing is 0.0 is 0.1 millimeters or 0.01 centimeters. Remember that to convert from a millimeter to a centimeter, we just divide by 10, right? So that's the accuracy of this instrument. So we use this to measure things like the diameter of a pen, thickness of a coin, and so forth. Notice that these are really small objects that we couldn't, like otherwise, measure accurately with a ruler, which is of the accuracy 0.1 centimeters, right? So the depth probe measures the depth of objects. Like if you want to measure the depth of a hole on a wooden plank, then you would want to use the depth probe. And then we have the external jaws. So if you want to measure, say, the diameter of a pen, you place it on the external jaws. But then if you want to measure, for example, the diameter of a test tube, you use the internal jaws. They measure the internal diameter. And then this is the Veneer scale. The Veneer scale. So this instrument is named after a certain scientist, a mathematician called Pierre Veneer. So that's why it's called the Veneer. The name is coined after him. That's the Veneer scale, and that's the main scale, right? Main scale. Okay, so now I want us to talk about how we obtain a reading from the Veneer caliper, right? So let's assume that you have placed your object between the jaws, and now you want to obtain a reading. The first thing to take care of is the scale. Is this a centimeter scale or a millimeter scale? With the Veneer caliper, it usually varies, but most of the times it's the centimeter scale. But you must be careful. In our case, it's the millimeter scale. So to obtain the length reading, we use this formula. The length or the final reading is given by the main scale reading plus the Veneer scale coincidence. The Veneer scale coincidence, Veneer coincidence times the accuracy. Let me remind you how the main scale looks like. This is the main scale. This long bar is the main scale, and then this is the Veneer scale. So we are saying the length is obtained by adding the main scale reading to the Veneer scale reading, right? The main scale reading to the Veneer scale reading. So, and we also mentioned that the accuracy is 0.1 millimeter or 0.01 centimeter. Now, because we are on a millimeter scale, we are going to use the 0.1 millimeter accuracy, right? The main scale reading is basically the division just before where the zero mark of the Veneer scale is. This is the zero mark of the Veneer scale, the 0, 5, and that's the 10th, 5, 6, 7, 8, 9. Okay, suppose the 10th, the 10th is on this bar, right? So the division just before the zero mark is this one. It's this one. So on the main scale, that's 50, 51, 52, 53, 54, right? That's the main scale reading. The main scale reading is 54. Main scale reading 54.0 millimeters, right? And then the next step is to take the Veneer scale reading. Now, you should listen carefully here. To do this, you find the mark on the Veneer scale that is lining up perfectly with the mark on the main scale. So we find the coincidence where the mark on the Veneer scale lines up perfectly with the mark on the main scale. Now let's go back to our diagram. Notice that this second reading lines up perfectly with this. Is this the second reading? Oh no, sorry. Let's wrap this off first. I didn't realize this. The zeroth division, the zeroth mark on the Veneer scale is here, because notice you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So the mark that lines up, the mark that lines up with the division before this Veneer, the zero of this Veneer scale is 53, not 54. The zero is here, so the division that comes immediately before the zero is 53. It's this one. I beg your pardon on that. So the main scale reading is 53 millimeters. And then the Veneer scale, where the coincidence is on the 1, 2, 3, on the third division, right? So the Veneer coincidence is on the third mark. Right. Now, the length of this object is obtained by the main scale reading 53 plus the Veneer coincidence times the accuracy. The accuracy is 0.1 millimeter. So that's 53 plus 0.3 millimeters, which is 53.3 millimeters. That's the reading that's on this Veneer caliper. Now let's look at this one quickly. So this is the centimeter scale. This is the centimeter scale. So that's the 0th division, the 5th, the 10th, right? Now the mark that comes before the 0 on the main scale is 3.1.2, 3.3, right? That's 3.3. So the main scale reading is 3.3 centimeters. And then the coincidence, the Veneer coincidence is, let's see, I think it's the second mark. It's the second mark. The third mark looks like it's coinciding, but not really. Look at the second mark. I think it lines up perfectly as compared to the third one, right? So the second mark, right? Now the final reading is the main scale reading 3.3 centimeters plus the Veneer coincidence 2 times the accuracy. The accuracy in centimeters is 0.01, right? 0.01 centimeters. So that's 3.3 centimeters plus 0.02 centimeters. So you add that, you get 3.32 centimeters. 3.32 centimeters. That's the reading. And that's how you take a reading from a Veneer caliper.